Hello, beautiful people, future me. Today in our programming workout, we are attacking execute program. We will start as always with a typing exercise on a typing IO. That's my favorite for the time being. And we will improve my typing, hopefully. Alright, so we still have a little bit of parallel exercises. That's good, let's go. Oh, well, that was short one. So what is the result? 1%. Oh, I wish it would be like so all the time. And lesson finished. All right, so we will find next one, and that is C++ WebKit. All right, let's do that. Star is here, yeah. Doing it. All right, that will be enough, I think, for typing. And 3%. All right, and we've been 42. Mhm. What? We have a sprint plan today? No, that was yesterday. All right. You heard nothing. All right. So I'm doing SQL review. Really? Mm, let's go in here. That looks like I started, but I did not do 12 examples. Hmm. Well, I have three topics to choose from. It is SQL, JavaScript, and TypeScript, I believe. And uh, so JavaScript, TypeScript, SQL, and Go. And the winner is SQL, looks like. hmm Oh, what it was SQL. SQL, yeah, so I will do the SQL then. So I have 12 code examples to review, so let's do that. It's time to review. Insert update exec returns. For those exec returns empty array. I can type error if the code will result in error, and that's it. So select 5 is not null as result, and that will be okay. So we will get the array, and result will be true, which here is 1 in SQLite. So this is correct. Drop the students, but they were executing Bob tables SQL injection as made famous by XKCD. If you get stuck, try using text editor to manually combine your a text string with other strings. Okay, so this will be. Oh, what do I want? I want to drop the table. All right. So first of all, I will close. I will close that statement, then I will begin a new one and I will say drop what happened? Drop drop table uh, students uh, and we need a comment, right? Comment and that comment out the rest of the line. So let me check once again. So we have the name, which we'll put that in there. That looks good to me. So let's try that. Oh, I'm kind of relieved. I was thinking maybe I would not be able to do it. Okay, so create a cats table with a text name and owner ID integer, foreign key that references the ID column of people table. Okay, so cats, and there will be two fields. One of them will be name, that is a text, and then we have a owner ID that is integer, and that references uh, people ID, I think. Looks good to me. Good. Now, what do we have here? We have creation of table with two fields, email name. Then, yeah, that's the one I did like million typos, right? So name or Cindy. So we are selecting email as the first. Then first is Amir at example. Amir at example.com. Okay, that's the first. And the second part of the result is also email because that is what we are selecting. And this one will be Betty. Ah, there is free. Oh, Cindy. Cindy at example.com, like so. Okay, so check for my nemesis, which is a typo, apparently. So email at amir at example.com and email Cindy at example.com. Hope for the best. Yay! Okay, select null plus one. Null plus null and any operation on it, like will result in null again. So this our result in here will be null. And I'm correct. Now what do we have here? We have two exec calls, exec function calls. So in first we are creating table people with two columns, ID and the name. Then we are creating a cat with owner ID, which is a foreign key pointing to people ID. And then we are doing some inserting and deleting. So first we insert uh, Betty, and then we insert Kinu. And Kinu is has the reference of Betty, right? So if we want to delete, uh, yeah, so we delete cats, the Kinu, that is no problem, and then delete. Oh, this one is fine, I think. Okay, so next thing is we are creating people and cats again. This looks the same as the in the previous example. Looks same to me. Now we are inserting Betty, then we are inserting Kino, well, Betty into people, Kino into cats, and we are deleting Betty. But Betty is now owner of the Kino. Well, I mean the field owner ID is referencing to the Betty ID in the people table. So that means we will get an error because of the integrity check in SQL. Now, next thing, we have constant email. Oh, okay. So now they want from me a result of this guy over here. Like this is the entire statement, right? And uh, we are putting in this place, we are putting that guy. So I'll copy that and paste it over in here. And that should be the thing we are getting. So we have insert into users, email, values, nothing, and we are dropping table users and we comment out the rest of the things. Is this here necessary? I don't know. Run. And I'm correct. Next one. We are creating a table of people. Creating table people. Two fields, two columns, ID and name. Then we have cat. That's the same thing as we did before. And now I already can see that we will get error. And the error is because we are inserting into cat with owner ID, which is not in the people table. So that means that I will turn off my confirm. Bye bye. Okay. And well, I'm back. Sorry for that. The one person who is viewing that for some reason. Alright, so this is an error because we are using a key, foreign key, which is not in the people's table. So error, go. Here's a table where some users have a cat and some don't. Select all users that have a cat. Hmm. Here, cat name is not null. And this is how I imagine it would go. Ah, that's the right and correct way how to answer this question. Next thing, create a table users. Email text unique, insert into users. Okay, so we have a table with users. They have just email, alright. And then we are dropping the table apparently. And then we are trying to select from users which no longer exist, so this will result in error. There we go. Next one. We create a table users. Now we do the injection to drop the table. And here the injection attack, and then we will get the error again because that's the same case as here. The users table no longer exists. And we are finishing our review. 2 lessons available. So I will choose randomly with the power of JavaScript. And okay, math, seal, seal. Yeah, this one I want. Bam, bam, and 2 it is. So constraint analysis. What a time to be alive. What if a foreign key column is null? Oh, by default, that's allowed. A cat with a null owner ID means this cat has no owner. Okay, so we have a table of people, ID name, cats, owner ID references people, and name text not null. Now we are inserting into cat with the owner ID null and name is fluff. And then we are selecting from cats and wow, it really let us do that. How awful. The database lets us do this because we might want it. Oh, really? For example, imagine that we are building a site where users can register with discount codes. Okay, some users register with a discount count, but others don't. We want to track which users registered which discount codes. With which discount codes, okay. This sounds simple, but there are a few subtle decisions to be made. Let's do some analysis to come up with appropriate database constraints. Our database will have two tables, discounts ID, discount code, and users with three fields ID, discount ID, name. We'll analyze the three most common types of constraints: foreign keys, nullability, and uniqueness. Okay, so foreign keys, uniqueness, I know, and nullability, I think we already did as well. First, should users discount ID be a foreign key to discounts? Yes. What? Okay, discount ID. Yes, otherwise users could reference discounts that don't exist, which doesn't make sense. Okay. Second, should every user have a discount ID, or is it okay for some of them to be null? Some users will register without using a discount code. For those users, discount ID should be null. So discount ID should be null. I see a point now. Third, can two users reference the same discount? This is more subtle decision. Mm. In some systems, discount codes can be used many times. In others, they can only be used once. We'll decide that discount codes can only be used once. We can guarantee that by making users' discount ID unique. If no two users can have the same discount ID, then no discount code can be used twice. Yeah, got it. That gives us three constraint decisions. Okay, so I will try to guess on my own. So first, uh, in the table discounts, the ID will be unique, right? Uh, then uh, this will be foreign key, and this will be unique here, right? So are these three things? Okay, user discount ID is foreign key to discounts. Oh, nullable. User discount ID is nullable, and user discount ID is unique. All right, so we are creating a table of users with ID, integer primary key, name, text, not null, and discount ID, integer references, discounts ID, null, unique. Create table discounts, ID, integer ID, and discount code, and this is not null, and this is primary key. Okay. Now let's check each of those constraints. Let's go. Each of these examples uses the table above, but the table always begin empty. If you think that a statement will cause an error, you can type error as its output. Remember that executing a successful insert returns empty array. So there are some comment in this statement. Users can't reference discounts that don't exist. So insert into users, and now we have empty discounts. Uh, so this will be error. Users can reference no discount at all. Discount ID can be null. Yeah, so this will pass. Okay, no problem. Users can reference discount. Okay, so we are inserting ID discount one-time use and some string. And here we are inserting users, and name is that, and here is this ID. So this is okay as well. Another example is two users can't reference the same discount. Emir uses the discount, then shares with Weddy, who tries to use it. Inserts into discounts, ID, discount code, values 1111. Yeah, and this here is the problem. So this will result in error, and we are correct. As you gain experience with SQL, you'll learn patterns about when certain constraints are appropriate. For example, users' email addresses are usually text, not null unique. Email addresses text, not null unique. Okay. An isAdmin flag will always be boolean, not null default false. That makes sense. And so on. Foreign keys are more tricky. For foreign keys, it's a good idea to always slow down and explicitly ask the questions what we asked above. Is it okay for a row to have no value for this foreign key? Okay, that's the first one, no value. Is it okay for two rows to have the same value for this foreign key? So it's the uniqueness. Here's another example where we ask the same questions, but we get very different answers. Users can post comments. Each comment has user ID referencing the user who posted. Now the analysis questions. First, should user ID be foreign key to users? On the comment? Yes. We don't want the database to think that comment was posted by someone who doesn't exist. It doesn't exist. Second, should every comment have user ID, a user ID? Yes. Or is it okay for some of them to have a null user ID? I don't think they should have null user ID. Every comment is posted by someone, unless the computer is haunted by ghost. So comments user ID should be not null. I agree. Third, can two comments reference the same user? Yes, sir. I think a user should be able to post more than one comment. Uh, like before, this one is more subtle, oh really? If only one comment can reference a given user, then trying to insert a second comment by the same user will error. A system with that constraint would only allow each user to post exactly one comment ever. We want users to post multiple comments, do we? So the comments user ID foreign key should not be unique. Yeah. Again. So the comments. Yeah, in that table. Yeah. Got it. Again, we have three constrained decisions, but when compared to the user discount example, we've made opposite decision about nullability and uniqueness. Comments user ID as a foreign key to users, the same as the user. slash discount. Comments user ID is not nullable. Yeah, the opposite of user discount. And the comments user ID is not unique. That's also the opposite to the previous example. So what do we have here? We are creating two tables, I see. One with the ID, integer primary key, and a name. Then second one has a user, and here are the constraints. And here is this one is not null. The uniqueness constraint is not here. And that's all there is to it. Now let's check each of those constraints like we did for the user discount example. Each of these examples use the tables above. Okay, so those are there, they are empty. And okay, let's go. Each of those examples uses the table above, but the tables always begin empty. Good. So, comments can't reference users that don't exist. Yeah, because this is the reference and we don't have it in the users table, so this will error out and I did not even read it. So this is insert comments user ID comment, yeah, and we are inserting one that's empty, so this is error. Comments must reference a user. User ID can't be null, which is in here. So Mr. Fluff needs a bath. Okay, now error. Error. Comments can be created with a user. What? Okay, so this one will just fly through with no problems because we have a user ID, one which is already in the table users. Go. Two commands can reference to the same user, and now we have one user and two commands pointing to the same user. This is no problem as well. Go. Our user slash discount example is what's often called one-to-one relationship. Ah, here we go. One-to-one relationship. Each user relates to 0 or 1 discounts. And each discount relates to 0 or 1 users. A user never has multiple discounts. And discount is never used by multiple users. Okay. The user comment example is one-to-many. That means like one user, many comments. Relationship. One user can have many comments, but comment is only related to one user. Okay, yeah, that's it. One to many, many to one. Okay. Shorthand terms like one-to-one and one-to-many are useful for talking to other developers, but the database doesn't know what they mean. The database only knows about constraints. Even if you use shorthand with other humans, you have to make decisions about the individual constraints in your tables. Should this column be a foreign key? Can this column be null? Can multiple rows have the same value for this column? So foreign key, not null, same value. And we are done. And also our clock currently is on 34 minutes, so that means we are done. And done every single time is better than perfect. So see you next time. Bye.